and vector search. So what is embeddings and vector search, that we have to go first, right? What is the need of it basically? So many people are now starting to think about how to bring Gen AI and LLMs to production service, and facing with several challenges basically. That's a that's what majorly people say, कि how we can implement, you can say, LLM based service, or you can say LLM based APIs to basically work with directly with our in a production, and how we can make it, how to make it abstraction level part, so that it make we can make the product at the production part. That's the main motive behind it actually, to go into it. Okay. So bringing Gen AI and LLMs to the production service. So you may wonder how to integrate LLMs and AI chatbots with maybe existing IT systems. It can be databases and business data. We have thousands of products, and how can I that like that? These are some questions. Like in a company, we have thousands of products. How can I let LLM memorize them all precisely? That's what the basic funda of to implement something. Like any question have arise, how we can implement it, or maybe how we can, if you go through LLMs, you pretty much know we tend to arise a question how to handle the hallucination issues in AI chatbots, to maybe to build a reliable service, something like that. So here is a quick solution: grounding with embeddings and vector search. That's the main. So what is grounding, and what are embeddings and vector search? So in this talk, we will try to learn these crucial concepts to build a reliable Gen AI service for enterprise use. That's what. So, but before we deep dive, here is an example. Okay. So again, Gen AI is not about just generating. Like the basic definition of Gen AI, that is generating AI to generate some content, and it can goes into the three aspect to it, about the understanding part of it, what that system reason to that particular thing is, and how we can generate that part, like what the answer we need. Maybe first, maybe suppose chat gpt is an example, Gemini is an example, you can say Llama is an example, where we are just generating out of it. Second, this is a text aspect. Second aspect can be stable diffusion models, which is more focused on the image part, basically how we can use stable diffusion model to generate that part, something like that. Okay. Now, so there is a demo, like I will go into it. So let me share link with you. So let me share. It's a like public demo. You can obviously use it, and I will basically do it. But let me open this thing at here. I guess just give me a moment. Let me open a new window, I guess, and let me reshare this thing with you. So yeah. So yeah, so this is a link. Let me share the link with you also. So what we will try to do here, selling. Okay. So let's try it. So this is built up on the Vertex AI Embeddings API. Okay. So let's suppose we are go to Stack Overflow text basically, and let me ask anything. Okay. So suppose we can ask maybe what is broadcasting in Python. Okay. And if you will see here, we get the lot of results around it. So even though there's a lot of topics around vectors, you can say a lot of topics around, you can say, broadcasting in Python in all over the internet, but these are the one. This is called the power of vector search. Like we are using vector search here to basically to basically map the major outputs behind it, and to shuffle down the other outputs. This is one of the example. You can always try it. I just give you Stack Overflow example because it is easy to understand, because we are developers and we pretty much know around it. Or maybe something, let me break down in something else. Suppose um, what is JavaScript engine, maybe something like that. Okay. So we will get, maybe if let me click over it. Okay. So it will tell about the each Stack Overflow links around it. So we are kind of wrapping it up in that sense. Okay. So this is the one of the demo which basically tells about how we can basically use, why it is a use of vector search. Like that's the major concept behind it, because LLMs or any machine learning model, any large big models, is very big. We have to surface around in the sense of, that's why the concept of RAG came into play. There's a lot of thing in internet we are scrapping out. We have to use for our personal use or maybe a specific use, so we can fine tune it using RAG and something like that. So that's what get into it. So this is what I'm telling you. Let me go to the my slides part basically. Yep. So if you will see here how to shuffle the, you can say how to shuffle in the SQL, something like can we get, and it basically gives the results and all. Okay, this is the part behind. Let me go to the next part. Okay, so now came around the major thing, what makes a demo unique, right? So let me, if the following point make this demo unique is like an LLM enabled semantic search. That's what we are doing. We are doing semantic search here. But if you understand here, the 8 million Stack Overflow questions, or it can be more than that, obviously, have questions and query text are both interpreted by by Vertex AI generative AI model. Okay, so the model understand the meaning and intent. When we say intent is the meaning of semantic. Maybe you heard about semantic analysis. Maybe a Twitter one is a very famous one when semantic analysis came into play. So how a tweet can we detect its what is the feeling of that particular tweet? It is good, it's bad, it's sad, it's happy, what that particular tweet is intending about it, right? Of the text or maybe of anything. So here we are focusing on the text and code snippet in the question body, if you'll say. So the this demo basically leverages this ability for finding high relative questions and goes far beyond the simple keyword search. Maybe in terms of user experience, I'm saying here. Okay, so for example, if you enter maybe how do I write a class that instantiates only once, then the demo show how to create a singleton class at the top at the model and knows their meaning, and same in the context of the computer programming, something like that. So grounded to business facts. So in this demo, we didn't try to have an LLM to memorize the 8 million items with complex, lengthy prompt engineering. Instead, we attach the Stack Overflow dataset here to the model as an external memory using vector search. And when we say external memory or private data or private memory, which is something work like RAG, that is retrieval augmented generation model, basically in that way. And use no prompt engineering, this means the output are all directly grounded, that means connected to this maybe a business facet of business facts, to be very precise, and not the artificial output from the LLMs. So the demo is ready to be served today as a production service with a mission critical business responsibility. Here I'm just going in depth. If you are an entrepreneur, or if you're working in an enterprise, how you can basically do it in that way and what is the need of it our. Okay, so it does not suffer from the limitation of LLM memory, or you can say unexpected behaviors of LLM such as hallucination. The major focus behind is that scalable and fast. That's the two things that we want. Scalable, how we can scale it, and how we can we make it much more faster in the terms of inference part, right? So the demo gives you the search result in 10 of million second. If you will see, it's very quick. It is very quick if you see the results around it, right? While retaining the deep semantic understanding capabilities. Also, the demo is capable of scaling out the handle thousand of search queries, you can say, every second. This is enabled with a combination of LLM embeddings and Google AI's vector search technology. What way we going to that part? So the key enabler, you can say in that way. So the key enabler R has to focus on the two things basically: the embeddings generated with Vertex AI embedding for text, and the fast and the scalar vector search by vector search AI search. Let's start by taking a look at these examples. So I guess Harshit is asking, can we train it on our own data? Yes, that's a rack concept behind it. You have some private data, you can fine tune it. You can fine tune that model. Suppose you have a JAMA model, and you have to basically go with your own data. Suppose you have a collection data of maybe something like related to hotels. Suppose you have private hotels data, you have to fine tune in the terms of, so that you can use for your own data. You don't have to basically go through, like, because it takes a lot of time if you train a lot of big models, right? So that's what the concept behind. Yes, you can obviously do it. Yeah. So understanding text with the Vertex AI embedding API. So before that, what is embeddings? That's the main thing that we are starting off, right? So What is embeddings? With the rise of LLMs or large language model, why it has become more important for an IT engineer and IDTMs to basically understand how they work. So let's work on some traditional IT system. How so in traditional IT systems, most data is organized as a structure or tabular data, maybe using simple keywords, labels, categories in database and search engines, right? That's what the basic database structure is, right? Right. In contrast, AI powered services arrange data into simple structure called embeddings, right? I'm not going into the depth of embedding, but something, suppose, think like in that way. Think in that way. Suppose you are a treat machine learning model, treat a machine learning model a baby who's just born right now, and you wanted to explain to call it papa, yeah, mama, or yeah, ma, suppose in that way, right? So it is doesn't like it get thing in one instant, right? It takes a lot of time to train it, or like explain it. Like it maybe take a year to basically say papa or mama, something like that. Basically, that's what is happening here. At the end, machine learning model is working on a computer, right? You have to tell, and at the end of the day, the machine at the binary level, only at number 0101 is the main game where computers is trained on, and this is a text data. So converting the text data into some value, that is called tokenization, where we are giving a specific value to a character or a word, you can say. And with that character, with that basically integer value of that particular thing, how we can make something like which, if there is two words, happy or sorrow, how it is related to them or it is not related. That's called the embedding concept came into play here, basically. I hope so you got it. Wow, got it. What I'm trying to tell you. Okay. So let's see how AI organizes data using embeddings, if you will see here. So if you will see here, so once trained with specific content like text, images, or any content, AI creates a space called embedding space, which is essentially a map of content meaning. So if you will see here, we have three things: movie, actor, and music, right? So it basically, if you will see, they're kind of relating to music with more or like actor, right? This is the called embedding space. How a music category is related to, or you can say music what is related to actor or a movie, if you will see here. So that's what came into play, and the major thing come around with it is like AI can identify the location of each content on the map. Let's take an example. So where a text discusses movies, music, and actor with a distribution of 10%, 2%, or maybe something like 30% respectively, suppose. So in this case, the AI can create an embedding with three values. Like if you will see 0.1, 0.02, and 0.3 in three-dimensional space, right? That just give you a 3D space, you can say in that way. Okay. And AI can put the content with similar meaning closely together in the space. So please note that like this specific example for purpose of explanation. So I'm not going into the actual how it got, but in reality, embedding space may have thousands, hundreds and thousands of dimensions that can represent almost infinite number of nano, you can say, categories of the content, right? So here I'm just give you an explanation. So according to it, if I give you a very brief definition of embeddings, so embeddings refers to the process of mapping high dimensional raw data such as images, text, which have a thousands or you can say millions of dimensions to a lower dimensional space using a deep learning model. This is done to extract the meaning or you can say semantics of the data to create a map of content meaning. What is the meaning of it? The meaning of it is we have to find out, we have to create a function so that we can find out each word. Can we give a feel to a one word so that how much they are interrelated to each other? That's a basic thing behind it. That's why we are finding out the embeddings of it, basically. Okay. And if you'll see here, this is how basically Google organizes the data. If you'll say across the various services like Google Search, YouTube, Google Play, or you can say Play Store to be very precise, and many others to provide search result and recommendation with relevant content. Embeddings can also be used to represent different type of things in businesses, such as product, users, user activity, conversation. music, video, maybe signals from IoT services or sensors, and so on, something like that, basically. Okay. AI and embeddings are now playing a crucial role in creating, you can say, new way of human computer interaction to make it more feasible while interacting with a computer. Like right now, as a coder, how we interact with our proper language, C++, Java, so to interact with the computer. But right now, it makes a more new space how we can interact with our model, or you can say computer at the end. So AI organizes the data into embeddings, which represent what the user is looking for, or the meaning of the content, or maybe and many other things you can offer done in your businesses and all that. But this create a new level of user experience that is becoming the new standard for making it. Okay. Now we have learned what is embedding. So let's see how we can use it with Vertex AI. Okay, so in, I guess I'm not remembering the exact date, but I guess it's around on May 10th, 2023. Google Cloud announced the Vertex AI embeddings API for text that is available on Vertex AI Model Garden. Obviously, you can explore it. Okay. This API is designed to extract the embeddings from the text. It can take up to, I guess, around 3K input tokens during that time. I am not remembering what right now. If they have I hope so. They increase some tokens, input tokens around it, and it give output around 768 dimensional text embeddings, basically something like that. Okay. Now let's, if we see with the embeddings API, you can apply you can say apply those skills on innovation part of it of embeddings and combine with LLM capabilities to provide text processing services. So first can be, you can say enabled semantic search, you can say. Okay. Second can be an LLM enabled text classification and recommendation. So these are some of the services. Obviously, I'm not going into the e-service, how it works, how it goes, and that way, basically. So yeah. So at, if we are sorting 8 million text at library level, like, so this is an example that we go into that. I didn't around that part, basically. So at the end of the day, major stuff that I want to show, let me share you, give one glimpse around it. Just give me a moment. Just give me a moment. So this is a vector space. Let me again reshare the screen with you. Let me share the link also so that it will be easy for you to. I hope so. It is visible to you, and this is the link. If you want to explore, you can still. So right. So if you will see here, you can get a more better. Yeah, if I can increase the more font size, right? It will give you what is the basic how we can basically relate each and everything, how it is relating and all. Right. If you will see database, right, how it is related to each other, it will give you a more better understanding how each word is connected to each, yeah, or maybe in that way, basically. This is stack overflow vector search embeddings, right? This is in, if you will see, these are the major chunks of stack overflow. If we are trying to fine tune, or using a rag based part of it, what are the embeddings look like at stack overflow? Like this is the way, like what are the most you can say, like if you will say node.js, something like majorly questions, how many questions are asked around it. Okay. So basically, Nomic AI, this is a Nomic AI, visualize the embedding space with 8 million Stack Overflow questions. And like you can basically go through it. Obviously, I shared the link with you. So obviously, there's not a problem in that, basically. Just give me a moment. Cool. Let me reshare the screen back to the PPT. Hmm. I guess now it's visible. Okay. So,
Karthike, Harshit is asking
yeah.
something in the same link. What was editor actually?
Like, so it's not, so basically this is a platform. There's a basically a company called Nomic AI, which basically created their platform where you can get your own embeddings, and you can visualize your embeddings. Basically, it's just a visualizer. You think in that way. It's just a visualizer, nothing else. It's just a visualizer. I hope so you got it. Yeah.
Okay, okay.
Cool. So here are the example of librarian level semantic understanding by embedding API with stack or flow question. So this is majorly, so for example, the model think the question does moving to a request line to the header frame requires an app change is similar to the question like does an application developed on HTTP 1.x version requires a modification to go to second like HTTP 2 basically. So that is because the model knows both question talk about what's the change required to support the HTTP 2 header frame. That's a kind of same thing. So this is the major thing how we can get into it, and that's what the concept of zero shot learning came into play. I'm not going into depth of machine learning here of that specific zero shot. So note that this demo didn't require any training or fine tuning with computer programming specific data sets. So this is the part where zero shot learning capabilities of LLM came into play. Okay, it can be applied to a wide variety of industries. So at the end of the day, zero shot method is a more extended version of transfer learning. Think in that way. Okay. The second key level of Stack Overflow demo, you can say it's a vector search technology. That's the main that we have to go into it actually. Okay. So the problem is how to find similar embeddings in the embedding space since the embeddings are the vectors. And this can be done by calculating the distance or similarity between the vectors. Okay, just give me a moment. Let me drink some water, I guess. Not till ask. Yeah, if you want some, or if you want to ask some question, I am okay with it. Just let me know. If everyone got till now what I actually sharing till now, or is there any questions till now? Let me know. Yep. Okay, I guess there's not a question, so we can move forward with it. Okay, so now that's a main question: how we can basically find the. So we came into the concept, and this I hope you will heard about. That's called similarity thing. So at the end of the day, ML's maths only. Okay, so you heard about it: dot product, vector product, something like that. Okay, so we go through three process basically. One is L2 distance, cosine similarity, and inner product that A dot B something like that, right? So these are the major thing how we can find out the distance between. So if there's a less distance, that means they are more near to each other and their or their interest, or maybe you can say their semantic or intent kind of same, right? So if you will say in that way, lol and happy is something kind of same because they have give same intent at the end of the day, right? Something like that. So, but this isn't easy when you have millions or billions of embedding. For example, if you have embeddings, 8 million embeddings with 760 dimension, you would need to repeat the calculation in order to that. So this would take a long time. Okay, but that's a concept behind it. That's why the cosine similarity is very common and common. It like maximum people use in that way actually. Okay, so the researcher have been studying a technique called approximation nearest neighbor. In a short form, you can say ANN. Basically, you can say in that way. So it's basically ANN uses a vector quantization for separating the space into multiple spaces with a tree structure. Have you seen there? Right? So this similar is to the index and relational database for improving the query performance or enabling very fast and scalable search. When if you have heard about Elasticsearch, you pretty much know about it. So that's the basic foundation to it, basically how you can do it. Okay. So I guess in 2020, the Google research published a new ANN algorithm called SKNN basically. So it considered one of the best ANN algorithm in the industry till now. So also the most foundation for search and recommendation in major Google services such as Google Search and YouTube, something like that. Okay. So here we are using, and Google Cloud developer can now take full advantage. With Lick, you can use it. It is in the Google Cloud. You can obviously use it, and you just have to go to the Vector AI search part, and you have to just enable this API to use it basically. Okay. Now, vector search offers not only a top-notch performance but also high scalability and reliability. And how we can use it? It is basically have a tight integration with Google Cloud services such as BigQuery, Vertex AI embedding API, and Feature Store, which can make your production ready MLOps pipeline, very seamless for data extraction, embeddings, generation, and vector search. That's what we want actually at the end, right? This is a basic, everything is interconnected, which is very easy for us to basically to build an app basically. Okay. Now, embeddings and vector search has already been deployed in many customer production system. So, for example, Mercury is the popular marketplace. You use the technology for showing the product recommendation. It is done by at the end of done by that actually. Okay. Now let's sing grounding LLM outputs for vector search or with vector search. So, for example, what if you want to show a similar items to a specific item the user specified? First, you get the embeddings for each item. Second, you can build an index on vector search with embeddings. That's why indexing is required, right? That's we want. And then you just run on a query on a vector search to find out similar item by their name by by a query basically. And that's you how you can start it with it. Okay. So this is a BigQuery table of the item and their names. In this example, let's simply use embeddings for the item name. So you can also use a description or you can say image to capture more detail meaning with the embeddings. But right now we are focusing on the text right now. Okay. So on a BigQuery, it is so easy to get embeddings for text. Just use ml.embed underscore text function. If you will see at the end, it is basically using in that way. So this function in your query, so you will get an embedding for a specific text column, which is very easy. Like you just have a function and you just have to embed that thing into your query. Despite of the simplicity, what you are getting here is the state of art LLM model, which is done by a text embedding like algorithm basically. Okay. And that means you can carefully organize your embedding space. That's really important because in an unorganized space of data can hamper your machine, your model inaccuracies part also. Okay, that's what didn't we want actually. Yes. So then export the embedding as a JSON file on a cloud storage, and this is exported as a like JSON file. And I so something like that. So this is the example that I'm showing you with it, and to go with it, go around it. Okay. Next, create an index with vector store. You can specify the cloud storage path of the JSON file along with a parameter such as dimension, number of items to fetch, similarity, measure type, etc. So if you're building an index with small or you can say mid-size item table, this process should finish within a minute. So, like, so it will run with this query basically to go with what like what you want at the end, like to basically go like with some dimension part around it. Okay. Last thing is to deploy the index on item, and it's very easy. You have to just find out the fix some of the endpoints around it and have to pass that as an to execute the vector search basically. Okay. Now it's ready to serve. You can run a query by passing an embedding of the specific item if you want to test it out for that part, and you will receive this list of similar item within 10 of milliseconds. Like you can check it. I can, as I earlier share a demo link with you, you can already go through in that way, and this is how it works basically. Okay. Now, I am not going with the very deep part of RAG part, even though it's not a part of this talk, but I will just give you a very faster overlook around how it works. So RAG is the key, RAG again, the thing how we can use private data to basically do it with that terms. Okay. So in this demo scenario, the user will interact with a chatbot through a text chat interface to ask question about various topic in Google. Like maybe if we take an example, if we're going with any paper, like Google research paper, suppose there's a lot of Google research paper out there, right? So, however, the challenge lies in the fact that LLMs are not capable to memorize the hundreds of documents, right? That's what the very limitation of it. Like it has hallucinate after some moment because it can't memorize. Like each node we can't memorize. If you go to the very old RNN stuff, also transform based, also still it's hallucinate at some point. Okay. So one solution is to use RAG model. This allows the LLM to conduct a vector search to locate relevant papers. What is the RAG? At the end of the day, you are using a small private data. You are fine tuning that particular on your private data with your you can say LLM. You can say any LLM service to basically fine tune for your own basis. Majorly, you can think it's a like of transfer learning something or transfer learning concept. You can say in that way. So after reading the papers, the LLM delivers a summarized response to the question utilizing the RAG models. You can say there's no need to train the LLM to memorize everything, which also reduces the risk of hallucination. That's what the basic concept behind of RAG, like why it came into existence. Like it will give you the actual prompt used in RAG sample code we provide. It consists you can say instruments for LLM such as use only the search result and like something like that, and you can check it around. Like it's a, like a just like a, I did this thing in my like in my, one of my demo, but I guess so I can share you that particular demo also. But I think so it's, I keep it down from Google Cloud because it's using my credits and all, something like that. I have to check it, but I hope so it's not available online also. So the rack system is a capable of having a conversation like this one, responding to the questions by leveraging the knowledge obtained through vector search. Okay, and however there is a, you can say we can consider, but RAG isn't a paniac. So although it's offer a more Gen AI like something like experience with its smooth text chat and conversational context, it also introduces risk of hallucination, because even though RAG came into the play, how we can make it very easy for us, but it's hallucinated at some point. Because suppose there is a large language model and you are hallucinating in the terms of the text generation. In contrast, simple vector search solution we provide explore a faster and most cost effective. So if you will see, RAG, vector search, these are important while you are implementing an LLM solution, because RAG gives RAG make the model not small, but it basically work on some small parts. Basically, you don't have to go at other area which is useless. And vector search is important, so it basically increases your basically the speed part, basically how we can basically search around it basically. Okay, so which gives you more cost effective search experience without the concern of hallucination. Okay, is it important to choose the right design based on your business requirement? That's what is important right now. Okay, and obviously you can obviously, I can share the links with you. Okay, so at the end I guess we share with the TFUG Hajipur team with the links and all about the blog channel. You can go through it, and you can check the, and if you have any doubt you can ping me on Twitter, on my Twitter or LinkedIn. I'm much more active on Twitter maybe, so like you can obviously reach out to me in LinkedIn also. There's not a problem in that. And yeah, thank you. I hope so you got something in that part. But yeah, good. Yeah, I hope so.